Alrighty guys, here we go with a little thing called the difference of, or the cube formula, sum and difference of cubes. But I'm starting off with something you learned from Algebra 1, and all of the things we're going to talk about, God, my voice, all of the things we're going to talk about are what we call factoring tricks. So I want to start you off with something you should recognize called the difference of two squares. The difference of two squares, well, I have several little examples here that we can start with. But this guy right here, when you factor it, it becomes x plus 6, x minus 6. You can trust me that that's the way it would break down, but if you are ever trying to check your work, you can always FOIL stuff to see. If I did that, I'd get that result. If I wanted to multiply these out, I'd get a positive 6x, and then 6 times negative 6 would be negative 36. These would cancel. Hey, I would get left with this guy and this guy. The thing is, recognizing when you see a factoring trick saves you a lot of time. So, just like they taught you in Algebra 1, you have to ask yourself, what would I have to multiply by itself to get an x squared? What would I have to multiply by itself to get x squared? Well, the answer would be x. And then what would I have to multiply by itself to get 36? Well, the answer would be 6. And then you take those two guys and plug it into your binomials. So I just did a couple quick ones here so we could just get this remembered real quick. So what times itself is x squared? That would be x. X times x is x squared. What times itself is 9? Well, that would be 3. So if you want to quickly factor this, you would say x plus 3, x minus 3. This is a technique called the difference. So to find the difference between two things, we subtract. So the difference of two squares. What times itself is x squared? X, well, that's a square. What times itself is 9? 3, that's a square. That's why they call it the difference of two squared things. Difference of squares. So, this one's a little bit more tricky, but it's not impossible. Never try to do a whole problem in your head at once if you can break it into components and make it easier. So this guy, well, what times itself is 49? You say, oh, 7 times 7. What times itself would give you that? Well, x. And then over here, this guy's easy peasy. I go, oh, that's just 9 times 9. That's 81. Once again, this thing is difference of squares, so the pattern would be 7x plus 9, 7x minus 9. And there you go. Now, the thing is, we are about to simplify a lot of things that have fractions in them. But what are fractions? Fractions are stuff in the numerator, stuff in the denominator. Sometimes the stuff that we see in one of these fractions is like one of these guys. And what our job is to break it down into its components, and we'll see if anything will go away or cancel out. So to do that correctly, I got to remind you there's something out there called difference of squares. But I wanted to put one example like this here because the first step in factoring is always look for a greatest common factor. Sometimes taking a GCF out of a problem is all you need to do, and it's done. But a lot of people try to jump on some technique or some trick or something else before they look for the little things. So look at this example, and what I'm trying to get at is this. Whoop. This guy has a 2. This guy's got an 8. I could take out a 2. That's a GCF. But wait, there's more. X fifth and X third. Pick on the little guy. X third comes out. See, when you are looking for a greatest common factor, it's always made up of the tiniest parts of the problem. It's true. It's weird. The greatest common factor, well, it's not 8. 8's greater than 2. No, no, no. Look at the 2. And x to the fifth is bigger than x to the third, but x to the fifth isn't the greatest common factor. It's always made up of the smallest stuff. So here we go. If I take that out, then what would I need? Well, let's work it backwards. Remember, taking out a GCF, now I'd say, you know what? I'd have to multiply that thing by x squared to generate this answer, and minus 4 to generate this answer, if I were to work it backwards. And then I look at this and I go, ho, I see you. You're right there. So I could break that part up and say it's x plus 2, x minus 2, but don't forget, we took this guy out at the beginning, so he is part of my answer. So in this video, I'm going over difference of squares because it's going to be important in our near future. But it's not new. It isn't. It's not new information. But I just want to remind you how to do it. This, however, I want to make sure you do not mess this up. There is no pattern we use for the sum of two squares. Remember, factoring patterns are going to be helpful for us to reduce information. You'll see that in the next video big time. But there is no pattern we use for sum of squares. So examples of things we won't have to factor, I made these guys up. Whoop, I don't want to show you everything yet. X squared plus 9. That's a square and that's a square, but that's not a difference. That's a sum. X squared plus 4. That's a square, but that's not a difference. That's a square, but that's not a difference. If it's the sum of two squared things, we cannot break it down to help us. So know the difference between difference of two squares and sum of two squares. Let that sink in for a second, because now I'm about to show you something new. This is something we do not show you in Algebra 1. This is something that we wait and we let you know this at Algebra 2 level. So here we go. Ready? The difference of cubes and the sum of cubes. Cubes are not squares, okay? Cubes are not squares. When you're saying squares, it's like what times itself gives you this. So like, if you're thinking of what are different square numbers out there, 4 is a square number, 9 is a square number, 25, 36, I could keep going, 49, 64. How am I magically coming up with all these? Not magic. I just know that that's 2 times itself. I know that's 3 times itself. Oops, I skipped over 4. 16 should have come next. But all I'm doing is squaring these numbers in my head to come up with the perfect square numbers. Well, we can do the same thing with cube numbers. We can do the same thing with cubes. So when we think about it, well, what are some perfect cube numbers? Well, what's 2 cubed? And if you don't know any of these numbers off the top of your head, you can check with a calculator. What's 2 cubed? It's 8. What's 3 cubed? It's 27. What's 4 cubed? It's 64. What's 5 cubed? It's 125. Now, etc., etc. I could keep going, but you could just punch these in on a calculator to get this done. And I'll let you know, I'm not going to pick some weird number. I'm not going to go, you know what, 9 cubed is 729. I'm not going to do that to you. I want you to understand the concept, but I'm not going to use some crazy, funky, big numbers. I need you to have conceptual understanding. Conceptual understanding. So, I'm about to show you how to do this type of problem here. Right here. X cubed plus 8. How do you break that up? And don't think, well, there is no way to do that because that's a sum. This is not squares. These are cubes. So we can do the difference of cubes, and we do have a formula for the sum of cubes. You can do this stuff. So, here's how this is going to work. Here's how this works, guys. If I have something cubed, now, different books use different letters. So, if I have anything that is in a cubed situation, so let's say a cubed. Well, what would that mean? That would just mean a times a times a, right? And I subtract from it something, let's say, b cubed. That's what our book uses. So I have something cubed, take away a different thing cubed. Well, what's b cubed? Well, it's just b times b, right? When we're talking about cubed things, it's anything times itself 3 times. So, the pattern is this. If you have something cubed take away another thing cubed, and I'm using a's and b's, then it will always factor to look like this. Let me just write it out, because the pattern never changes. There it is. It's a formula. It's a formula. So, once you determined what the cube thing is they're talking about, for A, well, you're going to replace it in the formula with these little locations here. Same thing with B. Once you know what you go and you go, oh, I'll put it here, here, and here, because that's where the B's go. Let me get rid of all those little marks I just made, because I'm going to walk you through some examples to make sure you got it. So I'm going to get rid of all those little marks so it doesn't look messy. Here we go. So that guy right there is the formula for cubes. And I'm also going to come down here and get rid of these A's and B's that I wrote in. Because when you check this formula out in the book, it's going to say this. Like, for sum of cubes, it will say something cubed plus a different thing cubed. And then here's how it breaks up. This is the pattern. This is the formula that we use. I'm just going to write it out. And I just noticed this when I wrote that out. This guy's supposed to be a plus. Whoops. I messed that up. Anyway, here we go. Difference of cubes is a formula. Sum of cubes is a formula. Pause it. Take a little picture of it. Or, better yet, write it down in your notebook. Because we're going to use this. It's going to happen to us. So the first example, I got examples ready to go. I got examples ready to go. And this one is the first guy I'm going to use. So here is something that I do for myself when I'm trying to learn something new. I look at this and I go, okay, this guy is a sum, and it's going to be a sum of cubes. So I'm going to recopy my formula down so I don't mess it up, like I did at the beginning. There we go. So there's my formula. I got to plug stuff into this. So in this case, instead of A, what do I have? What times itself 3 times is x cubed? Well, x. X times x times x is x cubed. So what I'm going to do is everywhere I see an A in this formula, I'm instead going to put an x wherever there's an a. Then, what times itself 3 times is 8? Well, that's 2 times 2 times 2. That would be 8. And so that means everywhere I see the letter B in the above formula, I'm going to put the number 2 in its place. So let's just do this. The original question says x cubed plus 8. What does that break up to look like? It breaks up to look like this. Not a, but x, plus not b, but 2. And then not a squared, I'm going to put an x squared. And then we don't write x2, that looks weird, so we just say 2x. And then plus b squared. Well, what would 2 squared look like? It would look like 4. And that is how you factor the sum of 2 cubes. The sum of 2 cubes. So here we go. I'm going to go down to this one. We got another one, but this one is the difference of cubes. So just like I did before, I know that the original formula says a cubed minus b cubed. Well, a cubed minus b cubed is a minus b times a squared plus ab plus b squared. That's what it looks like. But they don't want me to plug in a and b. They gave me a y. Well, what times itself 3 times is y cubed? And the answer is y. Everywhere I see an a in that formula, I'm going to put the letter y instead. What times itself 3 times is 125? Well, 5. And if you don't know, I'll show you on the calculator a way you can check to see if something is a perfect cube right away. It's under the math button on your calculator, by the way, if you want to know. But I'll show you in class. Anyway, the thing is, I don't say b equals -5. I don't. See, the formula has this already built into it. The sum formula, the only difference between the two formulas, take a look. I'm going to scroll up really fast before we do this question. The only difference in this formula is where the plus or minus signs are. The letter patterns are identical. It's true. That's how they look. So when it comes to a difference of cubes, the minuses and pluses are already built in for you. You don't have to say -5 for this question. It's fine. So what do? I go in here and where I see a, I'm going to put a y. Minus not b, I'm going to put a 5. And then instead of a squared, I say y squared. Instead of y5, that would sound crazy, I would say 5y. And then what's b squared? Well, they want me to take 5 and square it, so I'd say 25. And that is the way the answer will look for that problem. Now, I made up another one that looks a little bit spookier, but it's not. It's not that bad. This is the sum of 2 cubes. So once again, I'm writing out the formula every time. It's going to get burned into my brain if I keep doing this. So the sum of cubes is this one, where it's a plus b times a squared minus ab plus b squared. And that's what that formula looks like. So, just to get it through your head, this is what the question looks like. When we break it down into this, that's what the answer looks like. So, let's begin. Everywhere I see the letter A in that formula, I'm not going to put 8x cubed. No. Do it one piece at a time in your head. What times itself 3 times is 8? Well, that's 2. And what times itself 3 times is x cubed? X. So everywhere I see an A, I'm going to put a 2x. Let's do a same type of situation here. What times itself 3 times is 27? Well, I didn't pick a super crazy number. 3. 3 times 3 times 3. And then what times itself 3 times is y cubed? That's y. So I'm going to put that in for B. And let's not mess it up, because it's easy to mess some of this stuff up. I'm going to get rid of this big circle, though. Get it out of my way. And I'm going to say, instead of a plus b, I'm going to say 2x plus 3y. And instead of a squared, what do you think? If you say 2x squared, you're wrong. Remember, if you're going to square whatever a is, you're going to get 4x squared. Watch out. That's the biggest mistake people make. Minus a times b. Well, 2x times 3y would be 6xy. And then plus, don't make the mistake you might have made here. 3y squared will not be 3y squared. It'll be 9y squared. Now, you will notice something here. I'm going to erase that arrow, get it out of my way. You'll notice something here. This part of the problem, I have never ever said anything about. Because, here's the beauty of this. In the cube formula, the trinomial. See, this part here is a trinomial. This trinomial, in all of my answers, this part over here is trinomial. Not the first part, not the binomial, the trinomial. The trinomial portion of this answer, I'm going to use red to make this stand out. This part, this part of the formula, the red part, the red portion, the trinomial part, it won't factor. You never have to worry about trying to factor it. It will never break down. So, the thing is, if you know it's never going to break down, you plug in the stuff, you take a look at it and go, okay, I'm done, as long as you made sure you squared the correct things, etc. Now, I want to show you guys something that you will maybe see in your future in calculus, but you will definitely not see this in my class because I don't need to go there. But take a look at this one. This is technically the difference of cubes. It is. This guy is the difference of 2 cubes. So if this thing is the difference of 2 cubes, then it should break down to do this, and it does. It really does. But look, hey, I'm not going to be showing you anything that goes to this level. Doesn't mean it's not in your future in calculus, but here's the thing with this. It's kind of a trick question, and it's kind of an annoying question. Number one, not many people are walking around with this in their head. You know what? I bet if I multiplied 9 times itself 3 times, I'd get 729. But that's what it is. 9 cubed is 729. Number one, I don't have time to give you crazy, weird numbers to teach you a concept. But everywhere I see a B, I'm going to get rid of that little 3, keep my pattern. Everywhere I see a B, I could put a 9. And then, this is the other part that's sneaky, but this you should be able to wrap your mind around pretty easy. X to the 6th is actually a perfect cube. And you might go, well, how? Well, 6 isn't a perfect cube number. Yeah, but it's not being treated like a number. It's being treated like an exponent. So think of it this way. What if I took x squared times x squared times x squared? Isn't that cubing x squared? It is. Would that indeed be x to the 6th? Yes, it would. So that part you guys totally can wrap your mind around. You got that. But what I'm trying to say is that would be the a value I'd be using. Could I then plug x squared instead of a minus 9 instead of b? And then here's where you got to be careful. If I'm going to put an x squared there, that would be x squared squared. That'd be x to the 4th. Plus a times b. Well, I wouldn't say x squared 9. That looks weird, so I'd say 9x squared. And then I would say, well, b squared, that's just 9 squared, so that's 81. And that's awesome, and that's easy, and I'm done because I know this part right here, no matter what, it won't factor. And I'm not lying, it won't factor. I can't do anything about it. The trinomial portion of that formula will never factor, ever. But here's what I'm trying to get at. Oh, so sneaky, so sneaky. Think about how I started this lesson. What did I do to start this lesson? I gave you guys a review of something called the difference of squares. Take a look at that binomial. I said nothing about the binomial. The binomial there is factorable. And you might be going, what? Well, here we go. This would be the answer. If this was in your book, this would be the answer. X plus 3, x minus 3, x fourth plus 9x squared plus 81. That would be the final answer for that question. Now, like I said, I don't have time to get super intricate and crazy with this formula. So I'm not going to put something like that on your test. I won't, I promise. But that is in your future, and I want to make the point. You got to listen carefully in my video lessons. Sometimes you guys fast forward through me because you go, oh, I got it, I totally understand. And what I'm trying to do is give you a glimpse into your future sometimes, because the skills you pick up in this class will come back to bite you if you don't pay attention to them. So, let me just remind you here that this part right here, oh, come on, I'm trying to write really small, might factor. It might. You don't know. The second part, no way. There's no way you can factor the second part. But the first part, you got to be careful because it might factor on you. Now, there is one thing I did not do in this video, but I want to make sure you know this because this is the most annoying thing. This guy right here is the difference of squares. This guy is the difference of squares. Because what times itself is x squared? X. What times itself is 1? 1. So I could write that like this. But here is the thing. I'm not kidding you. The number 1 is a perfect everything. It's a perfect square. What times itself is 1? 1. 1 is a perfect cube. What times itself 3 times is 1? 1. 1 is a perfect fourth. 1 is a perfect fifth. What times itself 8 times is 1? 1. So you got to be careful with the number 1. 1 fits every pattern. So when you see this, and you're going to see this in one of the homework assignment things, you're going to see this guy, like x cubed minus 1. Okay? And then you're going to go, well, sometimes people draw a blank because 1 is so basic. But this would be my b value. This would be right? I would do this. That would be my stuff, and I'd go, oh, this is x minus 1 times, and then I would just fill in the blanks of the formula and call it a day. Okay? But be on the lookout. This guy's a stinker. 1 is a perfect cube, perfect square, perfect whatever you need it to be for this situation. All right, guys, so that is the cube stuff. Here's how this is going to work. There's only 4 practice problems here. So when you see this, these 4 practice problems that I'm about to show you, here they are. 1, 2, 3, 4. Here's the answer key right next to it. So if you want, jot down these 4 questions and then come back or take a picture of it with your phone or whatever and verify that you're getting the correct answers there, okay? But there's only 4 questions, so please do not turn this in to me separately. I am just going to ask you to turn this assignment in with the following one, which is going to be in the next video, okay? So you got 4 questions here just to make sure that you understand the practice. Now, here's the thing with this right here. This is something I wanted to do to you guys on purpose because some of you guys did this to me on the last test. Is that a plus sign or is that a minus sign? Huh? Which one is it? So, be careful. When you guys are writing stuff out, it's easy to make a plus sign out of a minus sign. But if you have a minus or a plus and you want to make it into a minus, it still looks like a plus sign. So do me a favor, and if this occurs, make it really clear what it is. So just say, that's a minus, Mr. B. Or, hey, Bogey, this guy, I don't care, use a different color or something. You guys, when I'm grading your test and you have one of these mysterious, could be a plus sign, could be a minus sign things, I was pretty nice. If that was the only boo-boo I saw on the whole page, the whole test, I looked the other way. But if you made other mistakes, then I get kind of like, hey, quit being so sloppy. This is a test. This is supposed to be the best work you can give me. So, make sure I can understand what it is, all right? Okay, that's it. So anyway, I'm going to catch you on the next lesson. That's it. Bye-bye.